Hello, good evening. Welcome to Thematic Lectures. This video is a continuation of episode number 1 about dynamics. So I will give you a quick review that what we learned in the introduction about dynamics. So what all things we learned in dynamics in introduction, especially we classified dynamics into two: kinetics and kinematics. Then we considered the classification of kinetics and kinematics, and we learned about its explanation or the definition of kinematics and kinetics, correct? And we finally learned about the motion, its classification: one-dimensional motion, two-dimensional motion, and three-dimensional motion. So as I said, today I would like to define the characteristics of motion. So especially the characteristics or specialities of motion, how we can analyze motion. What are the parameters or what are the variables that we are really concerned in analyzing a motion, especially distance, speed, okay, velocity, displacement, then acceleration, then average of speed, then average of velocity, instantaneous velocity, average acceleration, instantaneous acceleration, etc. Okay, so these are some of the parameters I really like to explain before moving into the concept of kinetics and kinematics. So what is distance? Suppose a particle is placed somewhere here in this position. As we know what is position, correct? So suppose the particle is at the position P1. Okay, so it traversed along a path and reached somewhere here. Okay, so the distance is defined as the total path length. So distance, we can define the total path length. Total path length. Is it clear? Total path length. So that is being measured either by different techniques for measurement, right? Either by tape, either by a scale. So whatever be the method of measuring, the total path length is the distance. Now, what is speed? So speed is defined as, we know that a particle, if a particle is in motion, how we identify a motion? If the position of a particle changes with time, then we can clearly say that a particle is in motion, right? So speed means the total distance divided by total distance traveled by a particle divided by the total time taken for that travel. So that is speed. Is it clear? So these two quantities, that is distance and speed, these two quantities are scalar. What is scalar? Scalar means we are only considering its magnitude or the value. We are not even considered the direction. So this category is known as scalar quantity. Now, what is vector quantity then? Vector quantity means we should consider direction along with its magnitude. Say for example, if you are going out for purchasing something from a supermarket, say 1.5 kilometer away from your home, that's your supermarket is 1.5 kilometer away from your home. In that case, you first went to supermarket for buying something and then you return back. So that means the total distance traveled is equal to 1.5, that is going to and fro, that is 1.5 again. That means 1.5 plus 1.5, that will give you 3 kilometers. So that is the magnitude. So that is the distance covered by the particle. Okay, then if you are introducing the direction into this quantity, so that means you went in a positive direction from your supermarket, that is exactly opposite to your original path. So 1.5 minus 1.5 will be 0. Okay, so what will be the net displacement in that case? Displacement means that is the magnitude by considering its direction. So in that case, the displacement is equal to 0. I hope you got it. Now, considering all these facts, first of all, I will define the displacement. So what is displacement? As I said in example, the displacement is, the definition is change in its position. Change in its position. Okay, so I would like to define displacement. I would like to define displacement. So what is displacement? I will consider with an example, P1 and P2. Suppose a vehicle is somewhere here at a position P1. After some time, it reaches here. So what will be the change in position? So this position is measured using a value x1. So that is x1 from the arbitrary point. Any arbitrary point, it is x1 distance away from any arbitrary point. And this is x2 distance away from that same arbitrary point. So in that case, displacement is equal to change in position, that is x2 minus x1. Is it clear? x2 minus x1. So that is a change in position, x2 minus x1. Obviously, this is a vector quantity. This is a vector quantity. So we should respect its direction. So that is displacement. So displacement is defined as change in position. Okay, so that is the underline that statement. I mean, especially change in position. Okay, so that is delta x is equal to x2 minus x1. Is it clear? So that's about the term displacement. Now, what is velocity then? What is velocity? Same scenario I'm considering. The same illustration. A vehicle is at a position x1 and it reached and another position at x2. Okay, so we are considering the time of frame also, please. So that means at this position x1, the time represents by the time t1, and when it's reached at x2, its time is t2. Okay, so what will be the change in time? What is the change in time? That is t2 minus t1, right? So that is a change in time. So during this time, the particle shifted or moved from x1 to x2. So velocity is defined as, it's the ratio of change in position with respect to time, change in time. So if you're writing an exam or equation for this, we know that what is change in position, that is represented by delta x, and time is represented by delta t. So velocity is equal to delta x by delta t. Correct? So this is about velocity. Okay, so in coming lectures, I will give some specific questions or specific example. Okay, how we can calculate velocity in special or in particular cases. Okay, so you should remember velocity purely depend upon displacement. Therefore, velocity is also a vector quantity. We should consider direction for velocity as well. I hope you got it. So this is the concept of velocity. So what all characteristics we learned? 1, distance. 2nd, speed. 3rd, displacement. 4th, velocity, right? So the first 2 categories falls under the category of scalar quantity. Now he has discussed some 2 characteristics that falls under vector quantity. Vector quantity means, I repeat, we should consider direction as well. Now, we need to consider what is acceleration. So what is acceleration? So you might be known about accelerator, right? So what is accelerator, or what is the purpose of accelerator? So accelerator in a vehicle, say for example in a car, so what is the purpose of an accelerator? An accelerator is used to change its speed. So for the clearer explanation, I would like to use velocity. Rather than using speed, I would like to use velocity. So change in velocity is happening when we are using, or when we are applying an accelerator, right? Okay, so there is a direct relationship between an accelerator and change in speed or change in velocity, right? So what will be the definition we are going to give for acceleration? So acceleration means it is a ratio of change in velocity divided by change in time. Change in velocity divided by change in time. Acceleration is equal to change in velocity by change in time. So what is change in velocity? Same illustration I would like to use. Same illustration. Same illustration. So what is it? Initially, this vehicle is having a velocity v1 at a time t1. So if we are applying a constant acceleration, of course, acceleration may or may not be constant. So I'm giving a constant acceleration. So I'm applying a constant effort using an accelerator to change its velocity. So now its velocity is v2. Is it clear? Now its velocity is v2. So according to the definition, this effort or this acceleration is a change in velocity by change in time. So what is the change in velocity? v2 minus v1. So change. Initially it was v1, now it becomes v2 at the time t2. And what will be the change in time? That is t2 minus t1. So the acceleration is equal to v2 minus v1 divided by t2 minus t1. So this is the definition for acceleration. So I hope you got the idea about this acceleration, velocity, displacement, speed, and distance. Now we are going to introduce some special cases into this. Like, for example, what is average acceleration? What is average velocity? Or what is average speed? Or what is instantaneous speed? Or what is instantaneous velocity? What is instantaneous acceleration? So, what is instantaneous? Instantaneous means velocity or acceleration at a particular instant. Or what is average? Average is the net effect. Suppose we are considering a span. In that span, what will be the average one? So that is about average. And what is instantaneous? At a particular instant. Okay, anyway, I will give you an idea about what is instantaneous and average. So first of all, we'll deal with the average speed. So what is average speed? Average speed is equal to the total distance covered divided by total time. It's a ratio. Okay. So suppose a man is at a position A. Now it reached at position B, and after some time he reached at C. So at that point A, the time is equal to, say for example, 0 seconds. Once he reached at B, he already covered 2 meters. At that time, t equal to 1 second. This is an example. This is not the real case. Now, what happens? He took 4 seconds more to reach at C. This is 10 meters away. This is 10 meters away. So my question, what will be the speed, average speed? What will be the average speed from the point A to C? The total distance. What is the total distance? Total distance is equal to 2 plus 10, right? 2 plus 10. What will be the total time? Oh, what is total time? From 0 to 5. What is the total time? That is 5 seconds, right? So that is going to be 12 divided by 5. So 12 divided by 5. 12 divided by 5. What is that? It is 2.2 meter per second. 2.2 meter per second. I mean 2.4. 2.4 meter per second. So this is the average speed of this particle from A to C. Does it make sense? I hope you got it. So this is the concept of average speed. Now, what is average velocity? What is average velocity? Next is average velocity. Average velocity. Average velocity is defined as the total displacement divided by total time. Okay, I will give you an example for understanding this concept very clearly. Okay, so I will be differentiated. I will be doing separate 2 questions, one with average speed, one with the average velocity. Then you will get a clear picture. What is average speed and what is velocity? Average velocity. Okay, so same scenario. I am considering A, B, and C. A, B, and C. So particle is at A at the time t equal to 0. Now he reached at the point B at the time t equal to 1 second. Now the particle reached at C at the time t equal to 2 seconds. Okay, t equal to 2 seconds. Now what happens is that he returned back to B. he returned back to B. Okay, so I will give you the distance as well in between. So from A to B, the distance is 2 meters. From B to C, the distance is 3 meters. Okay, so he reached, again, he reached. So I will show the direction as well. Okay, so A to B, then B to C, then C to B, and then he ultimately reached at the starting point. Came back to the same point. Okay, same point. At the point t equal to 4 seconds. So don't confuse, okay? So t is equal to 5 seconds. So ultimately, after 5 seconds, he returned to original position. So in this case, what will be the total displacement? Total displacement. So change in position. So change in position means final position minus initial position. So what is final position? Same starting point. What is the initial position? Starting point. So what will be the change? 0. What will be the total time? Okay. Therefore, average velocity is equal to total displacement by total time. So this is answer 0, right? So average velocity is equal to total displacement divided by total time. Okay. So I applied this equation. So that means ultimately I'm getting 0 by 5. Answer is 0 meter per second. I got 0 meter per second. I hope you got it, 0 meter per second. Now, what is average speed in this case? What is average speed? So average speed means, it is simple. Average speed means that is equal to, as I explained, or as I discussed, total distance divided by total time. So what will be the total distance covered in the same case? The total distance. The total distance is 2 plus 3 plus, again back 3 plus 2. So 2 plus 3 is 5. So 2 plus 3 plus 3 plus 2 divided by total time is 5. So that is equal to 2 plus 3, 5. 5 plus 5, that is going to be 10. 10 by 5. So that is equal to 2 meter per second. So here the total displacement, average velocity and average speed are not equal in the same case. So I hope you understood the difference between total displacement, total distance. So total displacement, we have to consider the direction. We should respect this displacement, direction. But in the case of total distance, we are only considering the magnitude, irrespective of the direction. Either it be positive direction or negative direction, we are only considering these two aspects. Now, finally, the last character I would like to describe here about this motion, that is instantaneous velocity and instantaneous acceleration. What is instantaneous acceleration? Instantaneous acceleration means, suppose a particle, instantaneous velocity means, suppose a particle is moving from A to B. So I would like to find what will be the velocity at a particular point, rather than finding the velocity from A to B or from one point to another point. I would like to find the velocity at a particular instant. Okay, so that means at a point, at a position, at that time is equal to t seconds. At that instance. So at that instance, what will be the velocity? it is x distance away from the starting point. So velocity is equal to, the definition says that we are not going to the derivation. Okay, so we are only considering the equations. So instantaneous velocity is defined as that is equal to dx by dt. dx by dt. So what is dx by dt? We have to differentiate displacement with respect to time, then we will get the instantaneous velocity. So that is equal to dx by dt. In some other lectures, definitely I will include the concept of instantaneous velocity, how we will get dx by dt, and I will explain with a graph. So in this video, I will give a fair idea about all these equations. So I repeat, instantaneous velocity is the velocity at a particular instant. So that is being calculated using the equation dx by dt. So we will use the concept of calculus to solve instantaneous velocity. Now, what is instantaneous acceleration? Same scenario I'm applying. Same scenario, same example. A particle is moving from A to B. At a particular instant, say for example at a t, at that point the velocity is v. So instantaneous acceleration is defined as rate of change of velocity with respect to time dv by dt. Okay, so that is equal to, we have to differentiate velocity with respect to time. So acceleration, instantaneous acceleration is equal to dv by dt. Okay, so instantaneous acceleration is equal to dv by dt. So this is about instantaneous velocity and instantaneous acceleration. So that's all about this video. So as a quick review, what all things we learned? We learned about speed. Before that, we learned about distance, velocity, acceleration, displacement, instantaneous velocity, instantaneous acceleration, right? And we learned about average speed, and average acceleration. What is average acceleration? Average acceleration is equal to, change in velocity by change in time. So that is v2 minus v1 divided by v2 minus d1. That is a simple definition, same definition as acceleration. So that is enough acceleration during a span. But instantaneous acceleration is particular time, at a particular time. So these are the things that we learn, we should remember before going into questions. Deal with the kinetics and the kinematics. Okay, so that's all for the day. So we'll continue this lecture. In the next video, I'll be giving some examples that's related with the one-dimensional motion. Okay, so I gave a fair idea about one-dimensional motion. In the next video, I'll giving you some scenario, that's some questions that are related with the one-dimensional motion, how we are going to practically apply these equations, and also I will explain kinematic equations. Thank you. Thanks for watching my video. If you have any doubt regarding these topics, please drop your comments. I will definitely update soon. Thank you.